Assalamualaikum dear students and viewers, welcome back to my channel CheMuneeb. In today's video, I will solve the paper of October number 24, variant 2nd of paper 1. So without wasting a single second, let's go through the paper now. The first question of this paper states that we have to find the different number of electrons from these species, and we can see that there are different compounds given. So basically we have to calculate electrons for every single species, only then we'll be able to find that which of these four contains different number of the electrons. Alright, starting from the first compound, which is Cl4O negative, we know that chlorine's atomic number is 17. You can check from the periodic table. So 17 electrons for the chlorine, and oxygen's atomic number is 8. And there are 4 atoms, which means 8 times 4, and then the negative charge indicate there should be one more electron of this whole compound, so I will add 1. If you calculate this value, it should become 50. So there are 50 electrons of this compound. Now for compound B, which is H2SO4, the atomic number of hydrogen is 1, for sulfur it is 16, and for oxygen it is 8 again. So the electron will become 2 plus 16, and 4 times 8 gives 32. The value will be 50. And for compound C, which is sulfate ion, we have 16 for the sulfur, then 4 atoms of oxygen give 32, and then 2 electrons from this 2 negative charge, it will give you 50. So all of them have 50 electrons each. Now compound D, which is selenium, if you look at its atomic number in the periodic table, the selenium is present over here. This is selenium. Now for this selenium, we can simply write 52 and then 2 electrons in it, additional 2 electrons, so it is 54. So the answer is 54 here. So this is the element, this is a species which has different number of electrons as compared to the other elements, so that's why the correct answer is D. Now the next question number 2, which factor causes helium to have a high first ionization energy than hydrogen? So here let's see the option A. 1s orbital in helium electrons are paired. So if we say the electrons are paired in 1s like this, we should have less ionization energy instead of high ionization energy, because pairing or spin pair, there is a fact of spin pair repulsion. So spin pair repulsion must account for the less ionization energy instead of the high ionization, so that is incorrect. The option B says the lowest ionization energy helium is filled. So yeah, the lowest energy is filled, but that doesn't account for the higher ionization energy as compared to the hydrogen. On the other hand, C, the nuclear charge in helium is higher than in hydrogen. Yes, there are 2 protons in helium and there is 1 proton in hydrogen. So more proton means more nuclear charge, and it has higher attraction for the valence electron. So because of higher attraction of 2 protons with 2 electrons in case of helium, this accounts for the higher ionization energy. And then D say there is less shielding of the outer shell in helium. So basically shielding we must have more shells. So but both helium and hydrogen have similar shielding because of the presence of only 1 shell. Both of them have 1 shell. So that doesn't account for the higher ionization energy. That's why the only option is, the right option is C. Now the next question is the repeated question from 2 different years, May June 17 and May June 11. You can also check out these questions on the YouTube to find the explanation for these questions from there. The question says that we have the aluminium carbide compound reacting with the water to form the methane gas. So basically we have to construct the equation here. So the equation which I can write here is aluminium we are given options, but I don't know which of these four options is the right one. So I will just write like this: A, L, X and C, Y. I don't know the number of atoms, so I will write like this. They react with the water, and as a result we get carbon dioxide and water as well. There is a mistake. The reaction of these two reactions give the compound of methane. We are getting methane as a result of this reaction. So methane is CH4. Now this CH4 is the only carbon containing compound. This methane is burning in excess oxygen. So I will write CH4 plus O2, and as a result of this we get CO2 plus water. Now we have to check that which aluminum compound was producing the compound of water having 108 cm cube, which means this Y atom of the compound AlXCY is responsible for producing Y times atoms of carbon of methane, and Y times molecules of methane are responsible for the production of Y moles of the carbon dioxide. For we can have this simple relation to find out the actual compound responsible for the formation of methane. So over here we will simply convert this value of the carbon dioxide volume into the moles. So number of moles of CO2 is equal to 108 divided by 24,000. Since this is the method to calculate moles, so the value will come out to be 0.0045 mole. Alright, we have calculated the number of moles. Now we have been given the mass of the aluminum carbide compound. So we can also check out the number of moles for every single compound present here. So for, let's suppose compound, the first compound A is Al2C3. If we want to calculate its mole, we first need to have the MR value of this compound. The MR value for all these compounds can be calculated. The atomic number of the mass of the aluminium is 27. So 27 times 2 plus carbon's mass is 12. So 12 times 3 is 36. This shall give you 90. So mass is 90 for this compound. You can similarly calculate the MR value for the other aluminum carbide compound. So 105 for this compound, 129 for this compound, and 144 for this compound. Now I have calculated the MR values. Now I have to find out the moles. The mole of first compound of Al2C3 is calculated as mass, and its mass is given. It is 0.216. So 0.216 divided by MR value is 90. So the value comes out to be 0.0024. Now this is the mole of the whole compound. I can infer from here that 1 mole of the Al2C, like this compound has this much moles, which means, as we know that 1 mole of the Al2C3 has 3 atoms of carbon, or you can say 3 moles of the carbon, which means if its mole is 0.0024 moles, then the number of carbon atoms or moles of carbon should be 3 times of this compound into 3. So this should give me 0.0072 moles of carbon. Now this value and this value doesn't match with each other. We did discuss that the carbon of this carbon dioxide is coming from the carbide. This Y of carbon is responsible for Y of methane, Y carbon of methane, and then Y carbon methane is responsible for the Y carbon of carbon dioxide, which means we should have equal values over here. So for this compound it doesn't match, which means we can now check the same value for the other compound. Now about the Al3C2. Now its MR value is already calculated to be 105. Now I will check the moles. The mole of this compound by using the same value of 0.216 gram gave me 0.0021. You can check from the calculator. So this is the mole of this whole compound. What about the moles of the carbon? So moles of the carbon will be equal to 0.0021 times 2. Since there are two atoms, so it should be multiplied by 2. The answer should be 0.0042. Now this is also not matching with this value, so it is not the compound. Now about Al3C4. The mole of this compound is 0.0017 mole, and the mole for the carbon will be equal to, if you multiply this value, we have, for this purpose we have to multiply with 4. Since there are 4 atoms in it, so its value will be 0.0068. This is also not matching. Now for compound D, the mole of this whole compound is 0.0015, and the moles of carbon is equal to 0.0015 times 3. So the answer is 0.0045. So this is the value which is matching with this one. So this and this compound are same, which means this is the right option. Now the next question, a reaction between two gases takes place on the surface of the catalytic converter of petrol engine car. So we have to look for the reactions which are occurring inside the catalytic converter. It says that the 4 reactant molecules produce 3 product molecules, which means the chemical equation should be there, which should reflect that there should be 3 product molecules and there should be 4 reactant molecules. According to the knowledge of catalytic converter, we know that the products which are obtained as a result of catalytic converter are these 3 compounds. We get less harmful compounds from the reactants, and these are the 3 less harmful products: N2, CO2, and then water. We always get these products. Whatever compound is there in the reactant, we should always get these products. Now which 4 reactant molecules should be there, that is mentioned here in the equation. The option A says that nitrogen is a reactant gas, and to no, this is a product. As we said before, this is a product, not the reactant, so it is not possible. However, carbon dioxide, that is also, yeah, carbon dioxide is also not the reactant, it is the product as mentioned here. So carbon dioxide is also not the reactant. The option B says that nitrogen monoxide, NO, yeah, this is the reactant, because the reactant which could be in the engine should be NO, it could be NO2, it could be unburned hydrocarbons, UHCs, and it would be CO. So these are the reactants, 4 reactant molecules which will produce these products. So NO could be the one, but carbon dioxide is not the reactant since it is a product. So B is wrong. Now option C says there is nitrogen monoxide, yes, NO is there, and carbon monoxide, yes, it is also there in the reactant. And D option says it is nitrogen dioxide. We can also consider NO2 to be the reactant, so it is also possible. And carbon monoxide to be the reactant, yes, it is also possible. But we have now 2 options to be correct. We have to be constructing the equation to find the right answer. Okay, let's apply for C option. We see that the nitrogen monoxide is the reactant and carbon monoxide is also the reactant, and if we have these 2 reactants, then the product that could only be formed should be N2 and carbon dioxide. We cannot write the water here since there is no hydrogen mentioned here, so it should not be there. Now balance this equation. Since there are 2 atoms of nitrogen, so I will write 2 over here, and now I have the 3 oxygen atoms on the left side and 2 oxygen atoms on the right side. So to balance that, I will write 2 over here. Now the oxygen atoms are balanced by putting 2 over here. So 2 carbon and 4 oxygen atoms on each side. So now this says that 4 reactant molecules should be there. Yes, we have now 4 molecules, 2 of this and 2 of this, and we should have 3 product molecules. So 1 mole of N2 and 2 moles of CO2. So yes, that is also there, which means the only correct option is C option. You can apply the same rule for the D option to find out the equation, but that will not be reflecting the statement. Now the next question, number 5. An ion contains 1 nitrogen atom and 2 hydrogen atoms. It has this much angle of approximately 105 degree. Which row is correct? So if you recall your knowledge from the chemical bonding chapter, we saw that the nitrogen when bonded with 3 hydrogen atoms is the ammonia. And the angle of this compound in HNH angle in this compound was 107 degree, 107.5 degree. So this is not the same compound here. It has 2 hydrogen atoms and its angle is different from this one, which means we will need to find the property of this N with 2 hydrogen atoms. So if we write NH2, that must have been obtained from the ammonia. So what we can conclude from here, that there must be a bond breaking from with the another hydrogen heterolytically. The bond must have been broken heterolytically, as a result of which both of the electrons of the hydrogen must have gone towards the nitrogen. So as a result of this, the N with 2 hydrogen atom must have the charge on it, because it has gained electrons of the hydrogen as well. So there should be a charge on it. So we could say this is the charge present. Now about the number of lone pairs around the nitrogen. As we know that there is already 1 lone pair in case of the ammonia molecule. So there should definitely 1 lone pair present on the nitrogen. But because of the bonding heterolytic bond breaking of hydrogen with nitrogen, the 1 electron of the nitrogen should come back to nitrogen like this, but the electron of the hydrogen should also be there, that has been gained by the nitrogen as a result of this heterolytic fission. Both electrons, this covalent single covalent bond has been gone towards the nitrogen. So 1 electron is gone back to the nitrogen, and additional electron of the hydrogen is there on the nitrogen. So we can see that there are now 2 lone pairs here. So 2 lone pairs are present in this molecule. So the right option from the first column would be 2. So as a result of this, the right option is D. Now the next question, number 6. Why does ICl have a higher boiling point than Br2? So we have to consider the presence of the intermolecular forces to account for the higher boiling point factor. Now the first option says that it is because the bond energies of covalent bonds are there in ICl and Br2. No, covalent bond has nothing to do with the boiling point, since boiling point is related with the intermolecular forces. So there is no connection of covalent bond with the boiling point. So A is omitted. The B option says it is because of the difference of polar nature of ICl and Br2. Alright, if we check the trend of the electronegative values going from top to bottom in the group number 7, fluorine the highest value of 4.0, and then chlorine has a value of 3.0, then bromine, and then iodine. You should have some knowledge from your literature about the values of these elements. It is better to learn these values. So iodine has 2.5, whereas bromine's value is in between of these two values. We don't clearly know, I don't clearly say, but it is somewhere in between them. So we say that iodine to chlorine should be this much difference. It is almost of 0.5 difference between them. And for bromine molecule, it is totally zero since both atoms are the same. So there is no difference in them, which means I will write here 0.5 difference and 0 difference here. So the polar nature could be the factor since there is a change of 0.5 in ICL but no change in Br2. So it could be the reason. Let's check the other option as well. The C option says that there is a difference in electrons contained within ICL and Br2. Okay, if we check the atomic number of I, the atomic number, iodine atomic number is 53 and chlorine atomic number is 17. So I will write 53 for iodine and 17 for chlorine, so its value will be 70, whereas the bromine's atomic number is 35. So 35 times 2, it is also equal to 70. So both of them have 70 electrons each, which means that there is no difference on the basis of the electrons. So C is incorrect, and the D option says it is because the difference in the relative molecular mass of ICL and Br2. So again, we can also check out their molecular masses because there is some connection of the mass. Like if we have very large size of the molecule, then as a result of this, that compound must have a higher melting or boiling point. So let's calculate the relative molecular masses as well. So iodine has 126.9 and bromine has chlorine has 35.5. So 126.9 plus 35.5 is equal to 162.4 gram, and for bromine the mass of one atom is 79.9. So for bromine, 79.9 times 2, it is equal to 159.8. Now the difference of 159.8 to 162 is not a large value. This almost similar. They are almost similar in masses. So we cannot say that the difference of a higher boiling point is because of this reason. So the only right option could be the B option, in which the polarity is the factor. We have 0.5 difference in ICL and no difference in Br2. Now question number 7. This is the numerical based question. In this question, you may assume that nitrogen behaves an ideal gas. So 1 atmosphere pressure is 101 kilopascal. Which volume does 1 gram nitrogen occupies at 50 degrees centigrade and pressure of 2 atmosphere? So we are supposed to find the volume. For this purpose, we must have the formula PV is equal to nRT. That's the formula you must have learned. Now we have to find the volume, which for this purpose we have to rearrange this equation in terms of volume. So it will become nRT over P. Now we do not have the value of moles here, so we will substitute the moles in terms of its variable. So it shall become mass over mR. So mass into R into T over mR for the mole into pressure. Now this is the formula here, but we have to substitute the values. The mR of nitrogen is N2. This is a diatomic molecule. So its value is 14 times 2 because its AR value is 14 into 2 gives 28. And the temperature over here is 50 degrees centigrade, which must be converted into the Kelvin. So it is converted by adding 273. So 273 plus 50 gives us 323 Kelvin. And the pressure The pressure must be indicated in terms of Pascal or kilopascal, but if we represent in terms of kilopascal, that would be fine. So if 1 atm is equal 1 atmosphere is equal to 101 kilopascal, then 2 atmosphere will be equal to 2 times 101. This is equal to 202 kilopascal. The mass of the nitrogen gas is already given here, that is 1 gram. So we substitute the values in this formula. So it should become, and as you know, this is a repeated question over here. So you can also find a solution on YouTube. So mass is 1, R value is constant, is 8.31, and temperature value is 323, and then MR value is 28, and the value of pressure is 202. Now if you calculate the answer comes out to be 0.47456, and that's the value in dm cube, because the relation of pressure to volume is, if we have the volume in dm cube, then the pressure value should be in kilopascal, and the value of volume is in meter cube, the pressure value should be in pascal. Since I have used the value in kilopascal, so that's why the volume should be in dm cube. Now I have to convert this value into the cm cube, which means I will multiply this value with 1000, since 1 dm cube is equal to 1000 cm cube. So multiply this value with 1000 should give me 470, let's say 475 almost. So 475 cm cube is the near value. So the only right option is closer to this value is 470 cm cube. So that's why the right option is 470. Now the next question, number 8, we have to prove which of these statements are correct. So such covalent compounds in which both oxygen and hydrogen are there should make hydrogen bonds? No, that is not correct. Because if we see the aldehyde compounds, you should have good knowledge of the organic chemistry for this question. In case of aldehydes, there is a bond of carbon, oxygen, carbonyl group is there, and then we have the hydrogen atom. But in this, and there is an alkyl chain or hydrogen atom with this. In this case, there is no hydrogen bonding, since the hydrogen is bonded directly with the carbon and oxygen is bonded with the carbon. There is a sigma negative on oxygen and sigma positive on hydrogen, but this is not fulfilling the requirement for the hydrogen bond. So that is not the case every time that compound containing oxygen and hydrogen should be responsible every time for making hydrogen bond. So it is not correct, especially in case of the aldehydes. The option B means having ionic bonds and covalent bonds cannot occur in the same compound. No, that is incorrect, since compound like NH4Cl is one example in which we have ammonium ions bonded with the chloride ions through ionic bond, and we do have the covalent bonding within the NH4, since NH4 means nitrogen is covalently bonded with 4 hydrogen atom, although there is one dative bond between one proton. So I can write like this, there is at least one dative bond in NH4 plus. So no, that is not correct, that there should not be ionic and covalent bonds at the same time. So B is incorrect. The option D says that only covalent bonds with high melting point are those with hydrogen bonds occur. No, we have a good example of the diamond. That is also, or they are saying covalent compound, so we have a good example of the silicon dioxide. It is a compound in which there is only covalent bonds. So there is no hydrogen bonding in this molecule. It does not fulfill the requirement for the hydrogen bonds. So it is not correct. And C says the ionic compounds differ from metals in that ionic compounds do not conduct electricity in the solid state. Yeah, that is correct, because in the solid state the ions movement is very restricted. They are very strongly bonded through ionic bond with each other. The positive ions and negative ions are very strongly bonded with each other, and as a result they are not freely movable or moving in the solid state, but when they are in the aqueous or molten form they can conduct electricity. So yes, C is a right option. Now next question is, for which reaction is the enthalpy change and enthalpy change of formation? Okay, for this purpose we must have a good knowledge of the definition of enthalpy change of formation. For this purpose I will show my notes of AS chemistry. These are my notes and these are complete AS chemistry notes. If you want, so you can let me know in the comment section. You can find here in the definition that it is enthalpy change when 1 mole of a compound is formed from its elements under standard conditions. So that definition is this: from its elements, and it should be 1 mole of the compound form, and the elements and products must be in their standard states, which means if they are in solid form at room temperature they should be mentioned as solid. So this is the definition. Now we apply the same definition in our question. In the option A, it says the carbon in gaseous form is reacting with the hydrogen gas in gaseous to make CH4. Now the mistake here is that carbon doesn't exist in the gaseous form at room temperature or standard condition. So this is incorrect. The C option says that Na2O solid form reacting with SO3 in gaseous to form compound. Although it looks right because we have 1 mole of the compound form and all of them are in the actual standard state, but the problem is that we should have elements, not the compounds. The element should be here and element should be here, not the compounds. So that is incorrect. And the option D is similarly showing the same mistake, that we should have elements here. This is correct, but this is incorrect. It should be element here, not the compound, to make the compound as a product. So D is also incorrect. However, the option B says that this is element, good. This is yes, this is element, and this is also an element, and they are present in the standard states of gaseous form, since both nitrogen and oxygen are gases, and they are producing compound which is also a gas. Nitrogen oxide is a gas, and 1 mole is there. So all of the rules of the definition or all of the keynotes of the definition applies here. So B is the right option. Now question number 10. The standard enthalpy change of formation is given here and we have to find the value. So basically we have to construct the half cycle here to find the right answer. I will show two ways to find the answer. One is the long route and the other is short route. The long route is that you have to construct the half cycle. So we can see that this is the overall equation. For this purpose I have to construct in the same way but with the half cycle. So 3VCl2 is converting into the 2VCl3 along with V. Now for half cycle, it says enthalpy formation of this compound and enthalpy formation of this compound, which means this and this compound must be produced from the elements. So the elements we have is vanadium and chlorine. Chlorine exists in the diatomic form. So vanadium and chlorine must be producing both the reactants and the products. There should be no error for the vanadium to vanadium element, since it is enthalpy change of formation for vanadium over here is 0. So we have now these and ways of arrows, direction of the arrows are these, but now we have to balance that. So if there are 3 vanadium elements on the left side, we must have, and there are 3 vanadium elements on the right side, which means we must put 3 over here. And the chlorine molecules, there are 6 on the reactant side and 6 on the product side, which means we have to put 3 over here to make them equal. So chlorine and vanadium elements are balanced. They are as they are asking what is enthalpy change for the reaction, which means this should be X and this would become A, this would become B. According to vector addition, X, according to vector addition, A plus X is equal to B. This is resultant vector. B is a resultant vector here. So X will become B minus A. Now the value of B is the enthalpy of formation of VCl3 that is given here. VCl3 value. Now it is basically 2 moles of VCl3 being produced, which means we will write 2 times moles of the VCl3 formation minus A is the formation of VCl2, but there are 3 moles of VCl2 produced. So we will write 3 times molecules of VCl2 that is given in the values form. We put the values here. So it should become 2 times of VCl3 means 2 times of the VCl3 is minus 573 minus, for the whole equation, 3 times of VCl2, and VCl2 is minus 452. Now if you calculate this value, you will get plus 210. Now plus 210 is the answer of this question. If I tell you the short form of this question is that you just simply put the formula delta H is equal to enthalpy of product minus enthalpy of the reactant, since we have the values in terms of enthalpy of formation and these compounds are inorganic. When we have these two conditions applied, when values are given other than combustion reaction, we are given enthalpy of formation or neutralization, etc., and then the compounds are inorganic compounds, then we can simply apply this formula. So product is, in this case, product is the VCl3 and there are 2 moles of VCl3 produced, and the reactant in this case is VCl2. So and there are 3 moles of the VCl2. So if you just put the values accordingly, you will get this equation over here. So you will get answer directly, and that's the answer. Now question number 11, equations for some reactions of hydrogen peroxide given. We have to tell which of these reaction is the one in which H2O2 is acting as a reducing agent. Hydrogen peroxide is H2O2. So for this purpose we must see that the other element must be reducing. So if we see here, iron 2 plus is changing into 3 plus. Now this is the oxidation process happening here. So it is not being reduced. Since we know that H2O2 is a reducing agent, which means it must be reducing iron, but it is not reducing iron. So 1 is incorrect. Now if we check option 2, then the only element which changes its oxidation state in terms of other than hydrogen peroxide, the only element is manganese. So let's check the manganese. Manganese is changing from plus 7 at here to plus 2, which means it is being reduced. Yes, it is being reduced. Now we have to look for the H2O2 as well. In case of H2O2, the charge on oxygen is minus 1, and in oxygen molecule it is 0, and in water it is minus 2. So it is changing from minus 1 to minus 2, that is reduction. This is reduction. And from minus 1 to 0, it is oxidation. So the one which is reducing agent must itself get oxidized. It should get oxidized. So yes, we can see that when H2O2 converted into O2, it is oxidized here. So this could be right equation. And the 3, again we check the change of the oxidation state. It is iron changing from plus 3 to plus 2. So yes, it is being reduced. The reduction is here. And in terms of H2O2, it is changing from minus 1 from here to 0 over here and minus 2 over here. So again it is changing from minus 1 to 0, that is oxidation, although it changes to minus 2 as well, but we will look for the oxidation as well. So oxidation is there in minus 1 to 0. So as a result of this case, we can consider that both equation 2 and 3, they are correct in this sense. So plus 7 to plus 2 and plus 3 to plus 2. So option equation third is also the right equation. So the right option becomes C option. Now question number 12. The equations are given here. The equation given between aqueous thiosulfate and aqueous dioxyvanadium (InVO2). We have to tell which of these two are the correct row. All right. This is a tricky question. I hope this will become a part of the examiner report, although it is not published yet. Okay, for this type of the reaction, we have to find the oxidation states of all the elements. Only then we'll be able to solve the question. So starting from the first reactant, that is S2O3, the state of the sulfur in this case, that could be determined from the oxygen atom. There are 3 oxygen atoms, which means the charge on the oxygen should be -6. Now to make 2 minus, the charge on the sulfur must be +4, which means +2 for one atom into 2 atoms. So the charge on one atom is +2. So that's how we get -2 charge of this whole molecule. Now VO2 plus. In this case, O2 will have -4 charge on it because there are 2 atoms of oxygen, and vanadium should give you +5. So +5 on one vanadium atom and -2 on one oxygen atom. And SO4O6 minus, we have to apply an equation to find the answer. So for S4O6, I will write separately. We have to find the oxygen state of sulfur. I will write it as 4x plus the oxygen state of oxygen will become 6 times -2. So 6 times -2, and it should be equal to -2 overall charge. So 4x and -12 gives me -2. So x will become 10 over 4, and the answer is 2.5. So the charge on one sulfur atom in this case is 2.5. For oxygen we calculated -12, and for sulfur it should be plus 2.5 times 4 atoms. Now for VO2 plus, the charge on oxygen is -2 and vanadium would give you +4, and on water it is now -2 and +1 for one hydrogen atom. Now we have calculated the charges. Now we have to apply other rules as well, like we have to check where is the change in the oxidation number. So the change in the oxidation is from vanadium +5 to +4. It changes from +5 to +4, and the change is of -1. The change in oxidation number is -1 over here. Now for sulfur, the change is from +2 to +2.5, which means the change over here is of +0.5. Now according to electrochemistry, we have to equal the change, which means this +0.5 must be multiplied with 2 to make it +1, and -1 is already there, which do not require to be multiplied. It could only be said to be multiplied with 1. So if the S2O3 is being multiplied by 2, then we have to check the charges as well. We have to find the charges, and we have to find the atoms as well. We have different ways to complete this equation. There is Y with hydrogen ion, but there is 4 water molecules, which means I can write 4 over here. So there are 4 hydrogen ions, and I cannot multiply this 2 with H2O3 since there are already 2 atoms here. Now I will check the number of oxygen atoms. So for calculation of oxygen atom, let's check from left side. There are 6 over here, and we have 2 over here. 6 plus 2 is equal to 8 oxygen atoms in the reactant side, and on the product side the oxygen atoms are 6 plus 1 plus 2, so this gives 9 oxygen atoms, so they are not balanced. To make them balanced, I will put 2 over here and 2 over here. So let's check now what is the change now in terms of oxygen atom. Now on the left side the oxygen atom will become 6 plus 4. This gives 10 oxygen atoms on the left side, and on the right side we have 6 plus 2 from here and plus 2. So there are 10 oxygen atoms. So now they are balanced. That was heat and trial base. Now check the charges. Charges should be there. In the reactant side, the charge on the S2O3 is 2 times into 2 negative. To 2 negative multiply with 2, so it gives me minus 4, and from VO2 plus it is 2 plus charge, 2 times plus, so it gives plus 2, and then 4 times plus means plus 4. So minus 4 cancel, plus 4 gives plus 2 on the left side, and on the right side we have 2 times 2, we have 2 minus over here, so minus 2 charge over here. 2 times 2 plus is plus 4, and then it is neutral, so it gives me plus 2 charge. So plus 2 and plus 2 are same on both sides, so this is also balanced in terms of the charges. Now we have the equation is balanced according to the atoms and then according to the charges. Let's see what they say about the options. They say that x and z are the same value. That is mentioned on every option. X and z are the same, so we do not look for that option, we look for the value of y. So x and z are same value and quarter the value of y, so we know that y is 4 and x is 2 and z is 2. So x and z are same but y is 4, which means x and z are basically half of the y. So C and D are the right options because x and z are both same but they are half of the y is 4. Now in second column we check the change the oxidation state of vanadium. So vanadium change from plus 5 to plus 4. So plus 5 to plus 4 is the right option from this column. So the right option becomes option number C. Now next question number 13. When solid Ca5PO43 is added to beaker, this is the equation. Which compound when added to the equilibrium mixture increases the amount of this compound? So we should know the reasons of the equilibrium to be moving towards the left side. So which factors could be the reason of for moving to the left is that we must have a higher amount of this ion, a higher amount of this ion, and a higher amount of this or a lower amount of this compound. So if we check the options, then apart from A, the other option says that NH4Cl should be added into the equilibrium mixture. I do not see any ion form which are similar to the product ions. So if we add NH4Cl in the solution, no single ion is matching with the product ion, which means that could be not be the option. Now C option says it is the ethanoic acid. Ethanoic is the acid and hydroxide is the base from the alkali. If they react with each other, it should decrease the amount of the OH. So this could not be the right option. C is incorrect. NaCl when added into the water becomes sodium ions and chloride ions. So again, there is no single ion matching with these ions. However, if we add NH3 to the solution which contains the water, then NH3 plus H2O will give ammonium hydroxide NH4OH, and NH4OH contains the hydroxide ion. Now if hydroxide ions are there in the mixture, then according to this equation hydroxide ions will amount hydroxide will be higher, which means according to Lee-Chatelier's principle it should move to the left side to decrease its amount. So when it will move to the left side, there will be an increased amount of this compound. So the only option is A option here by adding ammonia. Now question number 14, gaseous hydrogen and gaseous iodine react to form gaseous hydrogen iodide. Now we have this equation and we have the values given, 2 mole for hydrogen, 2 mole for iodine, and the Kc value is given, that is 9. We have to find out the moles of the hydrogen iodide present in the equation. Okay, for this purpose we have to find out two stages, the initial stage and the change in the stage. So initially there were 2 moles of hydrogen and there were 2 moles of the iodine, and at that moment Hi moles were 0. Now when there was a change, like we know that reactant moles should decrease and product moles should increase, which means the moles of the hydrogen should decrease by 2 minus x, like x amount of the hydrogen is produced, it is used, x amount of the hydrogen is used and x amount of the iodine is also used, which means the change should be 2 minus x for iodine as well. Both have decreased by x amount, and the amount of the Hi produced should be 2 times of the x, since there were 2 moles of the Hi produced. So this is the amount of the product formed. Now we have these values at equilibrium stage. Alright, now we have the Kc expression. The Kc expression says that the concentration of products divided by concentration of the reactants. We have H2 and I2 over here. Now we have to put the values. The Hi is 2x, so I will write 2x here, but it is a power of 2. The value is power of 2, which means this should become square over here, and it should become square like this. The H2 amount in equilibrium was 2 minus x, so it will become 2 minus x for H2, and similar for I2, 2 minus x. And the value of Kc, as we know, is equal to 9, so it is equal to 9. Now we have to solve this equation. This is the algebraic equation here. 2x square divided by 2 minus x into 2 minus x will also give 2 minus x whole square is equal to 9. Now take the square root of this expression and also this one. So this would give me 2x divided by 2 minus x is equal to 3. The square root of 9 is 3. Now from here, if you calculate the value of x, then using the expression, x will become equal to 1 over 2. You can calculate this value by rearranging the equation. Okay, now we have calculated the value of x. Now we have to find the value of hydrogen iodide at equilibrium. Since we said that Hi was 2x, which means 2x is equal to 2 times of 1.2. So this will become 2.4. Now 2.4 is the right answer, and this is the right option, D. Now next question number 15. Why does the rate of a gaseous reaction increase when pressures increase? This is also a repeated question from May-June 2013. Okay, by increasing the pressure, what could be the reason of increased rate of reaction? So option says that more particles have energy. No, it is related with the temperature, not with the pressure. So more particles have energy that exceed the activation energy. No, that is not correct. So it incorrect. B option says that particles have more space in which to move. No, pressure has inverse relation with the volume. So when we increase the pressure, then volume should decrease, which means there should be less space, not more space. So B is incorrect. C option says the particle move faster. Again, this is associated with the kinetic energy, which is associated with the temperature. So it is also not correct. And there are more frequent collisions between particles. So yes, when pressure is increased, then particles come closer together, and when they come closer together, there shall be frequent collisions between them. So the right option becomes D option. Now question number 16, the Boltzmann distribution curve for mixture of gases are capable of reaction. So we have two graphs of the Boltzmann curves along with the effect of the temperature and the catalyst at the same time. So you have to look for the two factors at the same time, the temperature factor and the use of catalyst. So they say which row is the correct. The first column says the number of particles with enough energy to react at 25 degrees centigrade, and the second column says at 35 degrees centigrade. So if you look at these two curves, we know that when there is a higher temperature, then as a result of higher peak shift to the right and lower position. So this peak, this one, if I label it, this is a peak which is shifted to the right and lower position at a higher temperature. So which means at 35 degrees centigrade, this should be the right peak. But you have to also consider the second factor. In the first column, it says catalyzed reaction, and the second column says uncatalyzed reaction. So when we apply the catalyst, we know that applying the catalyst, the vertical bar shifts to the left side, and when there is no catalyst, it is moved to the right side. So which means if we look for the first column at 25 degrees centigrade, then the peak which I am going to label, this should be the peak which we have to select, the one which is on the left side and higher value, and it should be catalyzed. So catalyzed position is over here, this is catalyzed position, so it should be this portion. So this portion says that Y and Z is there in the presence of the low temperature and in the presence of the catalyst, because this is the portion, this indicates the number of particles with enough energy. So this is the portion which should be included. So which means Y plus Z is the correct option from here. Now we check for the second column. The second column says that it should be of higher temperature. So higher temperature is the one which is labeled blue, and it should be uncatalyzed. The uncatalyzed part is mentioned here, which means the particles should be above this point. It should be above this point, and above this point the molecules present at a higher temperature are this one, this and this one. These are the molecules present, so which means X and Z are there at higher temperature and in the uncatalyzed portion. So up to this point we have the number of molecules. So X plus Z is a right option. So combining these two ticks, the correct option becomes the D option. Now question number 17, it is a repeated question from two different years, 2013 and 2018. The question says that which oxide is insoluble in aqueous sodium hydroxide? We know it is an alkaline solution. And among these four options, we have to check the oxide nature. This is acidic, this is acidic, this is amphoteric, but this one is basic oxide. So basic cannot be soluble in basic because there is no reaction between them. So the only right option is the option A, since we have to check the solubility. So base cannot is not soluble in the base. Now question number 18, sodium and sulfur are burned separately. So we have to check the right option. For this purpose, I will show my notes of AS chemistry again. In my notes, you can find the flame color. In my notes, you can find the flame color. The sodium flame color is basically yellow. Yellow or sometimes orange color is there for sodium. And for the sulfur, the flame color is the blue flame. So we have to select the right option from here. So for sodium, we will select the yellow flame, and for the sulfur, we will select the blue flame. That's the combination of C. C is the right answer from here. Now, question number 19. Question 19 says X and Y are elements in the period 3 of the periodic table. Okay, we have two elements. Y has a higher atomic number than X, which means that X should be present on the left of the period and Y should be present on the right of the period, because there is an increase in the atomic number. Now, it also says that the stable ion formed by Y has a greater radius than the stable ion formed by the X. We should know from the I will show the notes for this purpose. So for this purpose, we have to look at the atomic radius of the ions. So I'm going to show my AS chemistry notes again. Here in this page of my AS chemistry notes, you can see that the formation of the ions have this change in the size. The cations are these ones. These are the cations and they are present on the same period. This is the period number 3, and you can see clearly that when we switch from positive ion to the negative ion, then there is a sharp increase in the size. The reason is that these cations have lost their valence shell. The valence shell is lost in all of these cations, whereas the valence shell is there for the anions. That's why we see a sharp increase in size while moving from left to right across a period. So if we go back here, it says that the stable ion formed by Y, which means we could expect Y to be anion and X to be the cation. That's why Y has a greater radius as compared to X cation. It also says that stable ion formed by the Y has 18 electrons. So which means we do know that when we move across a period in the periodic table, we have 18 electrons in the third period, and this is argon. The elements of the anion in period 3 follow the electronic configuration of argon to having 18 electrons in them. So chlorine will follow this, sulfur will follow this, phosphorus will follow this. Silicon could follow both cation and the anion part. If it follows the anion side, then it would have 18 electrons, which means gain of 4 electrons. Gain of 4 electrons. And phosphorus will gain 3 electrons to make 18, sulfur will gain 2 electrons, and chlorine will gain 1 electron. Now we go back to the question. It says that the Y is forming 18 electrons by gaining whatsoever the number of electrons it gains, but it is making anion. We have to select the right option from these two columns. The first column says the number of electrons the stable ion of X. If we have checked that X is a cation, then it would not have 18 electrons, since it is a cation and it is losing its outermost shell. So the correct option will be 10, since it has lost its outermost shell, which had previously 8 electrons if it was there. So it would now have 10 electrons, and it would follow the electronic configuration of the next previous noble gas, which is neon. So it will follow electronic configuration of neon. And from second column, it says the element with a greater atomic radius. Now it doesn't say about the ion, it say about the atomic radius, which belongs to the neutral form of the atom. So when we said that while moving from left to right, there is an increase in the size from cation to anion. However, when we look for the atomic sizes, which means moving from left to right, then in that case, now in this case, the size of the atoms is decreasing across a period. So again, this is the third period, and we can see clearly the size is decreasing So when they are in the neutral form, the size will decrease. However, when they are in the ionic form, then the size will increase from cations to the anions. So we go back to the question, and in this question it says the size of which element will be greater. Since we know that y is on the right side and x is on the left side of the period, which means y should have less radius and x should have the greatest radius. So x would have greater radius than y, so x is there. So the option correct from this combination would be the option A. Now next question number 20. X is a group 2 element, either period 3 or period 5, and X hydroxide is less soluble in water than calcium hydroxide. Okay, now first check which could be the element. It says that X is the element either in period 3 or 5 and it relates with calcium. So we should know that in group 2, and it also present in group 2. So if I enlist all the elements of group 2, it is beryllium, magnesium, calcium, strontium. Beryllium is in period 2, magnesium period 3, calcium period 4, strontium period 5. So we have to tell it could be either element in period 3 or in period 5, which means magnesium or strontium. But then it also say that it is less soluble in water. So I'm going to show my notes again. In my notes you can see that the solubility of the hydroxide ion down the group increases. So going down the group, solubility increases, which means if we move upward, then the solubility will decrease. So which means it says that less soluble. So calcium comparing calcium, it could be the magnesium which is less soluble. However, strontium hydroxide is more soluble. So from column first, magnesium is the right answer. And then the second point is saying XNO3 or the nitrate of X is heated, it decomposes. Okay, so which means we have to look for the decomposition reaction of the nitrates of the group 2. So the nitrates are decomposed in this way, in which we have this type of the reaction. This is the general equation for the decomposition of the nitrate of metal group 2 of group 2 metals. It forms the oxide, it forms the nitrogen dioxide, and it forms the oxygen. So these three products are formed as a result of the decomposition. So over here the right option from this list is this one, in which oxide is formed, nitrogen dioxide formed, and oxygen. So this option and this option, they are both correct in this regard, but the combination of two ticks is option B. So B is the right answer. Alright students, that's all for today. In this video I have completed 20 questions of this paper. I will continue with the remaining question in my next video. Stay tuned, do subscribe my channel, and wait for my next video. Till then, take care, bye bye, and Allah Hafiz everyone.